All right, let's look at different kinds of problems we can do with piecewise functions. So in this example, we're going to write a function for this graph that we see right here. So there's two parts to this graph. I'm going to call this function f of x because apparently I'm feeling pretty boring. And the first thing I'm going to do is I'm going to find the two domains that f of x exists on. The first one goes from negative infinity all the way up to this point where it stops. And it stops right here when x is 0. Keep in mind you're using x's and not y's. So I'm going to say that this first function are for all the x's less than 0 and not equal to because that's an open circle. Okay. The second part of my function is going to be everywhere x is greater than or equal to 0. Okay, because this point is closed in right here. On the left-hand side, my y-intercept, if it were allowed to hit this point, would be 1. And my slope, you can see, is up 1 over 1, up 1 over 1. So it looks like that this function is x plus 1. That's the equation of this line right here. And that's nice and easy to see because you can tell what the y-intercept should be. For this bottom part, no matter where I am on this second domain, my function value is always 2. So the y value will be 2 no matter what, so we just put a 2 there. Okay. Let's look at the second function. I'm going to say that this second function has 3 parts. I'm going to call this g of x. And there are 3 separate domains for g of x. The first one goes from negative infinity until x is 1. And you can see right here that it equals 1. So I'm going to say anytime x is less than or equal to 1, I will have one function. The next piece is very tiny. It's in between 1 and 2. So I'm going to say 1, x is greater than but not equal to 1 in the second one because there's an open circle right here, and less than 2. And this third piece goes from 3, when x is 3 right here, all the way to infinity. So we would say anytime x is greater than, is the point closed? Oh, it is closed. Greater than or equal to 3. Those are my 3 domains. First domain, second domain, and the third domain right here from 3 to infinity. Okay, now I need the function values. So on this first domain, when x is less than or equal to 1, this is going to be negative 3, negative 4 all the way across. So it doesn't change. It just has a function value of negative 4. When I skip to this next domain, in between 1 and 2, it has a function value of negative 3. It's just a horizontal line, and the function is always negative 3 as long as I'm between 1 and 2. After 3, it gets a little more interesting. I can see that this is a line. I can see that its slope is 2. So I know that I have 2x, and then I have to figure out the y-intercept. So I can either calculate it out by using another point, or I can carry this slope all the way down and see if I can figure it out if I continue to this line. So if I kept going with a slope of 2, I would be here, and then I would be here, and then I would be here. And I would hit the y-axis right down here at 1, 2, 3, 4, 5. All right, at negative 5. The other thing I could do here, if I wanted to be really fancy, is I could say this is a point on my line, and this is a point on my line. And I know this line has a slope of 2, so I could use any one of those points and use point slope form from way back in the day. And I could say I'm going to use this point that I'm given right here, the starting point, because it equals 1 right here when x is 3. This is the point 3, 1. So I'm going to use that point, and I'm going to say y minus 1 equals my slope, which is 2, x minus 3. And this is point slope form. Hopefully you've seen this in Algebra 1. And then if I clean this up and get it to be y equals, because I have a function equals, so this y has to be alone, I would get y equals 2x minus 6, and then I would add this 1 over to the other side, plus 1. And I would still get y equals 2x plus 5. So you can either find the y-intercept visually by counting the slope down until you hit the y-axis, or you can find any point on the line that you're trying to do, and you'll see that, oh, that says plus, but I meant minus. You'll see that it ends up being the same thing. Where's my little eraser here? You want that to be a minus 5. If I were good, I would stop this video, but I'm too far in, guys. I'm not stopping it. We're just going to put a minus right there. Okay? So that is how we do this. Okay. Now, if you have functions and no graphs, you can evaluate these piecewise functions the same as you would evaluate any other function. You just need to be careful about which domain you're supposed to be in. So this part A says go to the f function and put in -6. Well, -6 is not greater than -1, is not in between -3 and -1, but it is less than -3. So it's only going to belong to one domain at a time because it's a function. So -6 belongs in this third domain. If I put -6 into this function here, because that's the function that goes with this domain, then I would say f of -6 is -6, which is 6. Okay. If I said f of -3, well, then I got to say, all right, well, what domain does -3 fit in? It's tempting to put it here, but do you see that it's not equal to -3 right there? You have to go go to the domain where x is allowed to equal -3, and that's in this second domain. So x is allowed to equal -3 in the second bucket here, and so its function value is automatically 4. 15 is greater than -1, so 15 belongs in this top bucket. It doesn't belong in any of these other domains, so I'm going to use this top function right here and say 15 plus 2 is 17. All right. D is skipping me over to K, so I have different domains. I have to find which one -11 fits into. -11 is not greater than 2. It's not in between -2 and +2, but it is less than -2. So -11 has to use this function right here. K of -11 is 4. All right. Now I'm going to go to my K function and find out which domain 1 belongs in. Is 1 less than -2? It is not. But it is in between -2 and +2. So I'm going to use this function right here, -x. So K of 1 is going to be negative, whatever my input is, so that's going to end up equaling -1. 318 is not less than -2, is not in between -2 and +2. It's down here in this bucket. It's greater than 2. So anything greater than 2, including 318, has to equal -4. Because all function values for x is greater than 2 are -4. K of 2, well, I have a domain where x is less than 2. I have a domain where x is greater than 2, but there is no function value at 2. K never has a range for x equals 2. So this one does not exist. There's no place where the domain for k equals 2. And now if I want to add these two things together, f of -10 and k of -10, I have to find both function values. So -10 in the x function belongs in this bottom bucket here because -10 is less than -3. So -10 is +10. That's for this first part. Now I'm going to travel over to k, and k of -10 is going to belong in this top bucket because -10 is less than -2. So that function value will be 4. So 10 plus 4 equals 14.